A very good evening to one and all. So today we are going to discuss the real life applications of trigonometry. First of all, trigonometry is the study of relationships among the sides and angles of triangles and derives its name from the Greek word for the triangle, trigonon. Real life uses of trigonometry include navigation, land surveying, global positioning system, GPS, applications, robotics, and the design of structures such as buildings and bridges. The height of Mount Everest, the world's tallest peak, was calculated using trigonometry long before it was scaled by mountaineers. Thank you. So plane trigonometry involves trigonometric relationships that occur on a flat plane such as a piece of paper, whereas the spherical trigonometry involves trigonometric relationships that occur on spheres such as planets. If the area being studied is small compared to the size of the sphere, it is often possible to obtain acceptably accurate results by using plane trigonometry for spherical problems. The grid systems that land surveyors use when laying out construction sites or locating property boundaries, for example, are formulated by assuming that its curved surface can be represented by a series of flat planes. Although it is relatively easy to perform trigonometric calculations using points that lie on any one of the flat planes, it is very difficult to perform calculations using points that lie more than one of the planes. So next, one of the fundamental mathematical concepts here is measuring angles of trigonometry. Plane angles are measured using wedge-shaped increments representing a fraction of a circle. The most common unit of angular momentum is the degree, which is denoted by a symbol circle, a small circle. A circle consists of 360 degrees. Thus, an angle of 1 degree is 1 by 360 of a circle. For every accurate measurements of angles, degrees can be expressed in decimal system. For example, 10.5 degrees, or in terms of minutes and seconds of arc. Each degree is divided into 60 minutes and each minute is divided into 60 seconds. In most branches of mathematics, including geometry and trigonometry, positive angles are measured counterclockwise from the positive x-axis. Angles measured clockwise from the x-axis are negative. The use of 60 rather than some other number, for example 10 or 100, to subdivide angles into minutes and seconds dates back to the Babylonian civilization, which arose around 1800 BC. The Babylonians used a base 60 number system for their financial and scientific calculations, so it was natural for them to divide each degree into 60 seconds and each second into 60 degrees. The reason behind the division of circles is into 360 degrees, however, is less obvious. One explanation is that the Babylonians recognized that the sun allows a nearly circular path through the sky each year, and that each Babylonian year considered as 360 days. Thus, each degree in a geometric circle corresponds to one day in the Babylonian calendar. Another possible reason has been inferred from a Babylonians clay tablet unearthed in 1936, which describes geometric relationships within a circle circumscribed around a hexagon. Next, the Babylonians knew that the perimeter of a hexagon is exactly 6 times the radius of a circumscribed circle, which led them to divide each of the 6 sides of the hexagon into 60 units, giving a total of 360 degrees in a circle. Babylonians are used to relationship between hexagons and circumscribed circles to make remarkably accurate estimate of the value of pi. Regardless of the reason why circles were divided into 360 degrees, it is convenient to integer to divisible by 2, 3, 4, 5, 6, 8, 9, 10, 12, 15, 18, 20, 24 and 30 as such fractions as 1 by 2 or 1 by 5. Okay, 1 by 5 of a circle can be represented by an integer member of degrees. Thank you. Thanks a lot.